Properties of integers, closure, commutative, associative, and distributive property. We'll see how these are valid for integers. Closure property. Closure property states that if an arithmetic operation on any two integers is always an integer, then integers are closed under that arithmetic operation. Arithmetic operation means it can be either addition, subtraction, multiplication, or division. While doing these different arithmetic operations on two different integers, we have to see whether the result is a integer or not. Addition. Let us consider adding two integers, one negative integer, negative 36 plus 12. This results in a negative 24 as sum. So here, while doing addition operation on two different integers, the resultant value is also a integer, which means closure property holds for addition of integers. Subtraction. Consider two different integers again. I am taking the same integers, negative 36 and 12. Here, this is a negative one and 12 is a positive integer. Now we are going to subtract these two integers. The difference here would be negative 48. So this negative 48 is also a integer. So doing subtraction on two integers is again resulting in an integer as difference. With this we can tell that closure property holds for subtraction of integers. Multiplication. Again we have negative 36 and 12. If we multiply these two integers, the product is negative 432, which is also a integer. Closure property also holds for multiplication of integers. Now let us check what happens in a division. While dividing two different integers, again if I take the same values like negative 36 and 12, one is negative and other is positive. If I do division here, the quotient would be negative 3, which is an integer. By this, we may think that closure property holds for division as well. But now if I take some other combination of integers like negative 4 divided by 8. So this we can write like this as well. After completing this, we'll have negative 1 by 2 as the quotient, or we may write it as negative zero point 0.5. This is a decimal. Integers don't have decimals in it, so this cannot be an integer. Negative zero point 0.5 is not an integer. So while performing division on two different integers, the quotient may or may not be an integer, because of which we can tell that closure property doesn't hold for division of integers. So to summarize this closure property, we can tell that it holds for addition, subtraction and multiplication of integers, but it doesn't hold for division of integers. Now let us look into the next property, commutative property. Commutative property states that the numbers on which we operate can be moved or swapped from their positions without making any difference to the answer. Here also we have to consider all four arithmetic operations and see whether this commutative property is satisfied or not. First, for addition, We'll take two different integers like again 36 and negative 12. If I have to do addition for this, adding these two things will give us an answer that is 24. Now when we swap the places, means we'll write this first and this one will go second. So we are just swapping the position of both the integers and we are going to perform the same arithmetic operation again. So even in this case we'll have 24. Here we can observe that swapping the position of the integers didn't change the result. So both are same, which means addition of integers is commutative. When it comes for subtraction, consider two integers again, 36, negative 12. We have to subtract now, minus. So this will get simplified like this and then we can write the answer as 48. Now swap the positions. This comes first, negative 12. And this integer goes next, that is 36. We are going to do subtraction again. As both have got negative sign, we will add it, but we'll keep the negative sign before this. So when we compare the results, here it is 48, but here it is negative 48, which means they are not same. So subtraction of integers is not counted. Multiplication. Again, if we perform multiplication on two integers, one positive and one negative, the result in product is negative 432. Swap the positions of both the integers and perform the same operation, that is multiplication. Here also we'll get the result as negative 432. Both are matching, which means multiplication of integers is counted. Now division. Consider any two values. I'm taking the same values. Now we got to divide these two integers. When we divide, both are of different signs. So negative 3 is the answer. Swap the positions. Negative 12 divided by 36. This results in negative 1 by 3 as a result. Here we can clearly observe the difference. It is negative 3. Here it is negative 1 by 3. They are in same. So division of integers is not commutative. To summarize the commutative property for integers, addition and multiplication of integers is commutative, whereas subtraction and division of integers is not commutative. Next, associative property. Associative property is a property of arithmetic operations which states that rearranging the parentheses in an expression will not change the result. We'll see what is this. Now again we'll do this for all four arithmetic operations. Here rearranging the parentheses means we have to do the operation in a different way, for which we need more than two integers involvement here. So we'll take three integers and see this property. So let us take simple numbers like negative 2, 3 and 1. So we have to do addition of three numbers. So what we usually do, we'll do for two integers first and the result will be added to the third one. Initially, we will take these two. Minus 2 plus 3 is 1 plus this one here, 1 plus 1 is 2. Now, for performing the same arithmetic operation, I will first consider the last two integers first, that is 3 plus 1. This will come as this negative 2 plus 3 plus 1 is 4. So here also the resultant value is 2. Both are same, which means addition of integers is associative. Subtraction. Consider the same values again, negative 2, 3 and 1. We have to subtract now. So again we'll consider first two, negative 2, negative 3, same signs. So add and keep the sign, negative 5. This one comes as this, minus 1. So again same sign, so we'll add and keep the negative sign, minus 6. Now we'll rearrange the parentheses and consider. So this time we'll consider last two first. So negative 2, here 3 minus 1 is 2. So negative 2 minus 2, which is here again negative and negative. So add and keep the negative sign. Negative 4 is the answer. In the first case, we got negative 6 as the answer, whereas in the second case, we got negative 4 as the answer. The answers differ, they are in matching, which shows that associative property is not applicable for subtraction of integers. Now consider multiplication for associative property. Again considering the same values 2, 3, 1. Multiply this. First we'll multiply these two. Negative 2 into 3 is negative 6 into 1 is negative 6. Again perform multiplication by rearranging the parentheses. We'll consider last two. So negative 2 into 3 into 1 is 3. And again this is negative 2 into 3 is negative 6. Both the answers are matching. So multiplication of integers is associative. Consider division now. We'll take different values. Negative 18, 6 and 3. We have to perform division. So initially we'll consider these two. So negative 18 divided by 6 is negative 3. Divided by 3 is equal to negative 1. So perform the same operation but by changing the parenthesis position. So negative 18 divided by 6 divided by 3 is 2. So now negative 18 divided by 2 is 9. Negative 9. So both the results are not matching, which shows that division of integers is not associative. When we summarize the associative property for integers, addition and multiplication of integers are associative, whereas subtraction and division they are not associative. The next one is distributive property. So in distributive property also we have two different things. One is like distributive property of multiplication over addition and distributive property of multiplication over subtraction. First is for addition. If we take this for any three integers x, y, z, we can tell that x into y plus z is equal to x into y plus x into z. Consider any three different values and check this. I am taking same values 1. So here it is like multiplication and plus. Now when we do this, what happens? Negative 2 into 4, which is negative 8. So this part is resulting in negative 8 as answer. I am substituting the same values for x and y. X value is negative 2 into y is 3 plus x is negative 2 into 1. Negative 2 into 3 is negative 6 plus negative 2 into 1 is negative 2 itself. So this is this, which is equal to negative 8. Both the values are matching, which shows that Distributive property of multiplication over addition. This particular property is satisfied by integers. Now we'll see for subtraction. Again it is the same, but here instead of plus we are keeping minus sign. So consider the same values. X is negative 2, y is 3 and z is 1. On completing this, we'll have 3 minus 1 is 2. The value here is negative 4. Substituting the same values here, minus 2 into 1. So minus 2 into 3 is 6, minus 2 into 1 is minus 2. So here same signs, so plus 2. Now it would be minus 4. Here both the results are matching, which shows that distributive property of multiplication over subtraction is applicable for integers as well. So in this video, we have covered all the four properties for integers.